Imagine peering 13 billion light-years into the void, where the James Webb Space Telescope uncovers ancient black holes older than stars, galaxies, spinning in impossible sync, and signals from rogue worlds that scream across the cosmos. These revelations shatter everything we thought we knew about reality, hinting at a universe far wilder and more dangerous than imagined. If mind-bending cosmic secrets keep you up at night, smash that like button and subscribe, because what I'm about to show you will redefine existence itself. Prepare yourselves. We begin. Picture the universe as this colossal breathing entity, a vast expanse that's been inflating since the Big Bang, like an endless party balloon pushed by invisible forces. We've always imagined it expanding smoothly, predictably, with stars and galaxies drifting apart at rates we could calculate on the back of a napkin. But now, thanks to the James Webb Space Telescope, known as James Webb for short, that tidy picture is cracking wide open, revealing a cosmic crisis that's got scientists wide-eyed and whispering about the end of everything we know. This is the Hubble tension, a sneaky discrepancy that's not just a math error, but a potential fracture in the very laws governing our reality. It's like discovering your trusty global positioning system is lying about distances, leading you to question if the road itself is warping beneath your tires. Buckle up, because as we dive into this expansion enigma, you'll see why James Webb's gaze is forcing us to rewrite the universe's rulebook. To set the stage, let's rewind a bit to how we even measure this cosmic stretch. The Hubble constant, named after Edwin Hubble, who spotted the universe's recession in the 1920s, quantifies how fast galaxies flee from us, about 70 kilometers per second, for every megaparsec of distance. Early tools like the Hubble Space Telescope use standard candles like Type 1a supernovae, which explode with consistent brightness, letting us gauge far-off distances like lighthouses in the fog. These local measurements pegged the rate at around 73 kilometers per second per megaparsec, painting a universe accelerating, thanks to dark energy, that mysterious 68% of everything pushing outward. It all fit neatly into the lambda cold dark matter model, our go-to framework for cosmology, blending cold dark matter with a cosmological constant. But then came the cosmic microwave background, that faint afterglow of the Big Bang, mapped by satellites like Planck. That relic radiation from when the universe was just 380,000 years old suggested a slower 67 kilometers per second per megaparsec. A gap of 6 kilometers per second per megaparsec might sound tiny, but on cosmic scales, it's a chasm wide enough to swallow theories whole. Enter James Webb, launched in 2021, but hitting its stride in 2025 with sharper infrared vision that pierces the dust veils hiding the early universe. This beast doesn't just look at dissects light from billions of years ago, splitting spectra to reveal chemical fingerprints and motion clues. In its first deep dives, like the physics at high angular resolution in nearby galaxies, survey mapping nearby galaxies, James Webb confirmed the local rate with unprecedented precision. Using Cepheid variables, those rhythmic pulsing stars, Hubble relied on James Webb measured distances to over 1,000 supernovae, cross-checked against gravitational wave events for ironclad accuracy. The result, the tension holds firm, if not worsens. Adam Ries, the Nobel-winning astronomer, who's chased this ghost for years, declared in a 2025 paper that James Webb's data seals the deal no more, hiding behind calibration errors. It's as if the telescope is shouting, "Hey, your models are broken. Listen to the stars." Why does this feel so urgent, like a thriller, where the plot twists keep coming? Because the discrepancy implies the universe isn't uniform. If early expansion was slower as cosmic microwave background data insists, then something kicked into overdrive later on. Dark energy, once thought a steady hum, might be dynamic, waxing and waning, like the tide influenced by quantum fields or exotic particles we haven't dreamed up yet. Picture it in the universe's youth. Gravity dominated clustering matter into proto-galaxies. But as space stretched, dark energy awoke, shoving everything apart with increasing fury. James Webb's observations of distant quasars, those blazing beacons powered by black holes, show light redshifted in patterns that scream acceleration mismatches. In one stunning 2025 find from the James Webb Advanced Deep Extragalactic Survey Program, light from a galaxy 13 billion light-years away arrived with blue shifts in certain lines, hinting at localized slowdowns amid the rush. It's chaotic, almost alive, as if the cosmos has mood swings we can't predict. Let's humanize this a touch. Who's sweating over these numbers in the labs teams at NASA's Goddard Space Flight Center? Huddle over petabytes of data running simulations on supercomputers that mimic the Big Bang's echoes. Wendy Friedman, another tension hunter, led James Webb's Tully-Fisher relation studies using galaxy rotations as alternative rulers. Her 2025 results nudged the constant to 70, but still no bridge across the divide. It's collaborative frenzy. Europeans from European space agencies Planck mission clash. Notes with American supernova squads, debating if intervening dust or peculiar velocities, galaxies' sideways drifts, are the culprits. Yet James Webb's mid-infrared filters strip away dust illusions, showing the raw truth. And in a plot twist, baryon acoustic oscillations, ripples in galaxy distributions from the early universe, align more with the cosmic microwave background, deepening the local anomaly. Now imagine the ripple effects on our cosmic story. If the Hubble constant varies, the universe's age shrinks or stretches. Standard clocks say 13.8 billion years, but a faster local rate implies we're younger, squeezing star formation into tighter timelines. James Webb spots galaxies at redshift 10, just 480 million years post-bang, already brimming with stars. How if expansion was sluggish back then? This ties into inflation theory, that explosive growth in the first instance where quantum fluctuations seeded the structure we see. But if tension persists, inflation models falter. Maybe multiple inflatons, scalar fields driving bursts, explain the jerk in speeds. Or worse, we're in a bubble of our multiverse, where local physics diverges from the grand average. Cepheids sure, but string theory enthusiasts are buzzing, proposing extra dimensions, leaking energy to tweak the constant. Diving deeper into James Webb's toolkit, its near-infrared camera captures Cepheids in the Large Magellanic Cloud with resolution down to arcseconds, nailing parallaxes that ground distances in solid geometry. Paired with the mid-infrared instrument, it probes cooler stars, revealing hidden populations that refine the cosmic ladder. A 2025 study in Nature analyzed 42 lens-assisted supernovae, where gravity bends light to multiply views, confirming the 73 kilometers per second per megaparsec locally, while early cosmic microwave background holds at 67. The math, it's brutal. Sigma equals 3.5, meaning less than 0.03% chance of fluke. Critics like Ethan Siegel argue for systematic offsets in supernova light curves, but James Webb's spectra debunk that, showing consistent nickel lines across events. No escape, the universe is inconsistent. Philosophically, this shakes the foundations. Einstein's general relativity assumes isotropy, same in all directions, but tension hints at anisotropy, a lopsided cosmos. James Webb's panoramic views of clusters like Max 0416.1, expanding slower filaments, faster, carving a web of uneven growth. Could this be modified Newtonian dynamics, ditching dark matter for tweaked gravity at low accelerations? Proponents say yes. A 2025 simulation matched James Webb data without dark energy, but it struggles with cosmic microwave background scales. Alternatives: quintessence fields, rolling potentials that evolve, or chameleon particles that hide in dense regions. Each theory paints a universe in flux where constants aren't constant, challenging the elegance we crave. The drama escalates with real-time data drops. In October 2025, James Webb's Cycle 3 observations targeted the Fornax cluster, measuring peculiar velocities that amplify local biases. Galaxies there zip at 1,000 kilometers per second, skewing distance estimates by 5%, but even corrected tension endures. Gravitational waves from LIGO-Virgo mergers offer independent checks. Neutron star distances align with the fast rate bolstering the case. It's a detective story, with James Webb as the star witness pointing to new physics. Perhaps early dark energy. A brief phase post-recombination resolved the horizon problem, but left a scar in expansion. Or interacting dark energy, swapping energy with matter, smoothing the curve imperfectly. As we grapple with these shadows, the human toll emerges. Sleepless nights for postdocs funding fights over bigger telescopes. Yet excitement trumps frustration. This could unify quantum gravity, explaining black hole paradoxes too. Loop quantum cosmology suggests discrete spacetime, where expansion quanta jitter, mimicking tension. Holographic principles from anti-de Sitter / conformal field theory hint are three-dimensional reality projects from a two-dimensional boundary with inherent inconsistencies. Wild right, but James Webb's empirical hammer tests these ideas, sifting truth from fancy. Zoom to everyday impacts. If dark energy evolves the Big Rip, where expansion shreds galaxies, then atoms looms closer or recedes. A faster constant shortens the timeline to trillions of years slower. We fade to heat death sooner. For astrobiology, it reshapes habitable zones, accelerated void star of planets of metals. James Webb's exoplanet hunts tie-in spotting worlds in expanding clusters, where time dilation warps evolution. Ethereal, but grounded in data, from TRAPPIST-1 analogs at high redshifts. Critiques abound, keeping the fire alive. Some blame local group motion. Our 600 kilometers per second drift toward the great attractor, but corrections via cosmic microwave background dipole don't suffice. Others eye evolutionary effects in supernovae progenitors, changing over time, but James Webb's progenitor imaging rules that out. A 2025 controversy erupted over Hubble flow in voids versus walls, with Cosmic Flows 4 catalog showing 10% rate variances. It's messy science, but that's the thrill, pursuing truth amid chaos. Historically, tensions like this birthed breakthroughs. The 1998 acceleration discovery flipped cosmology. Now this could do the same. Hubble himself faced skepticism today. James Webb echoes that spirit, probing deeper than ever. Future synergies with Roman Space Telescope will map billions of galaxies, potentially resolving or exploding the crisis. Until then, we speculate, is the universe a simulation glitching, or a black hole's innards pulsing? Theories abound, but data rules. The emotional pull, it humbles us. We thought we cracked the code, but James Webb reveals we're novices in an infinite library. This expansion crisis isn't defeat. It's invitation to explore further. As measurements refine, perhaps a tired light revival, redshift from scattering, not expansion or void models prevail. But whatever unravels it, the journey redefines wonder. And just when this speed puzzle has you reeling, James Webb's next bombshell, those monster galaxies popping up way too early, will make the tension feel like a mere warm-up to the real cosmic horror show. To truly immerse in the Hubble tension's web, consider the mathematical heartbeat. The Friedman equation, Hubble squared equals 8 pi g over 3 rho minus kc squared over a squared, plus lambda over 3 balances, density curvature, and the constant. Tension arises when plugging in parameters. Cosmic microwave background yields omega matter equals 0.3. 1 omega lambda equals 0.69. For Hubble 0 equals 67. Local demands higher lambda or lower matter. James Webb's baryon fraction from X-ray clusters matches cosmic microwave background, but supernova luminosity distances don't. It's a thermodynamic puzzle. 2 entropy in accelerating space versus static models. Delve into specific missions. The supernova Hubble for the equation of state project, using James Webb's fine guidance sensor for guide stars, achieved 1% precision on Cepheids in NGC 4258. Masers there. Natural lasers anchor the latter geometrically. Meanwhile, dark energy spectroscopic instruments 2025 baryon acoustic oscillation maps show W equals -0.8 for dark energy evolving toward phantom. Synergies reveal, if early Hubble 0 was 50, inflation needs tuning by factors of 10 to the 10th. Personal stories add flavor. Reza recalls late nights, recalibrating Hubble data only for James Webb to validate doubts. Young researchers like Victoria Venn hear echoes of Galileo challenging orthodoxy. Conferences buzz with debates. International Astronomical Union 2025 featured sessions where holography proponents clashed with quintessence enthusiasts. Broader cosmos ties tension, affects nucleosynthesis, light element abundances like helium-4. Faster expansion dilutes neutrons, less boosting deuterium, but Big Bang nucleosynthesis fits slow rate. James Webb's metal-poor stars confirm primordial ratios, heightening paradox. Technological feats shine. James Webb's cryo-cooler maintains 7 Kelvin for mid-infrared instrument, detecting 0.6 micron shifts in spectra. Data pipelines use artificial intelligence to sift signals from noise processing 20 gigabytes per day. It's engineering poetry, turning photons into philosophical bombs. Alternative universes beckon. In cyclic models, bounces resolve tension by varying constants per cycle. Emergent gravity, Berlinda's entropic force, predicts rate from information density. James Webb's black hole mass functions test these, finding overweight early voids. Cultural impact documentaries like Cosmic Crisis 2025 dramatize the hunt, boosting public awe. Schools incorporate it, sparking science, technology, engineering, and mathematics dreams. It's not abstract, it's our story in the stars, yet doubts linger. If dust extinction is underestimated by 0.05, magnitudes rates align, but James Webb's ultraviolet imaging spectrograph debunks. Peculiar velocities from dark energy survey average 300 kilometers per second, but not enough. The chase continues, each clue a thread in the tapestry. Finally, as this crisis simmers, remember, it's the gateway to greater mysteries, like those behemoth galaxies, defying time itself, waiting to stun you next. To flesh out analogies, think of the universe as an ocean. Cosmic microwave background is the calm surface waves. From the storm's start, local measurements, turbulent currents, near shore. James Webb dives below, finding eddies, where dark energy swirls erratically. Or a symphony, early notes, slow and deliberate, later frantic conductor gravity, losing control. Scientist spotlights, Friedman's tip of the iceberg method, with tip of the red giant branch stars, gives Hubble 0 equals 69.8, middle ground, but tension lingers. Reese pushes local Skolnick's pantheon, plus sample reinforces 73. Debates at American Astronomical Society meetings are electric, with slides flying like accusations. Data deluge, James Webb generates 57 gigabytes per day archived at Space Telescope Science Institute. Machine learning clusters supernovae spotting outliers that tweak rates. 2025's General Observer Program 1783 targeted 50 high redshift events. Theoretical playgrounds in Brain World models our universe on a membrane. Bulk gravity leaks affect Hubble 0. James Webb's galaxy alignments test bulk flows, or F of R gravity modifying Einstein-Hilbert action for cosmic acceleration without lambda. Interdisciplinary links, tension impacts particle physics, neutrino masses from cosmic microwave background, but local probes, axions, or sterile neutrinos. James Webb's neutrino backgrounds from supernovae spectra could clinch. Public engagement TED Talks by Rias draw millions, explaining tension as the universe's midlife crisis. Museums feature James Webb holograms simulating expansion. Challenges ahead: light pollution analogs in space, intergalactic medium absorption, but James Webb's near-infrared spectrograph overcomes. Future Vera C. Rubin Observatory will survey millions cross-validating. The poetic side expansion crisis echoes existential voids our place in the stretch. It reminds of Hubble's awe we find ourselves in a dimly lit, sparsely furnished room. James Webb lights the corners. Thus, as this crisis unfolds, it primes us for the shocker of early behemoths, galaxies born too soon in the cosmic dawn. Let's explore the historical arc more vividly. In 1929, Hubble's law emerged from Vestos Slipher's redshifts and Henrietta Leavitt's Cepheid periods. Post-World War II, Walter Body refined it, but acceleration hid until Saul Perlmutter and Ries's 1998 supernova surveys. Planck's 2013 cosmic microwave background locked the slow rate igniting the fire. James Webb, with its 6.5-meter mirror, 100 times Hubble's sensitivity, escalates it. Key papers Raz and others 2025 in Astrophysical Journal, using 1,200 Cepheids sigma equals 1.8%, for Hubble 0 equals 73.04. Planck's legacy favors 67.4. Discrepancy equals 5 sigma discovery level. Implications for structure formation. Sigma 8 clustering amplitude mismatches. If tension real, James Webb's weak lensing in cosmic evolution survey Webb shows overdense early fields. This suggests warm dark matter or self-interacting particles, smoothing small scales. Exotic solutions. K-essence kinetic dark energy with speed of sound variations. Or back reaction, where inhomogeneities average to effective acceleration. Bouchard equations model this matching James Webb voids. Observational frontiers. Gaia data, release 4 2026 preview ties in, with 2 billion stars parallaxes. Combined Hubble 0 precision to 0.5%. But if tension persists, new era dawns. The mystery's allure lies in its intractability. Like dark matter hunts, it drives innovation. From artificial intelligence anomaly detection to quantum sensors, James Webb catalyzes progress. In quiet moments it inspires. If expansion betrays us, what else does? The universe vast and veiled calls us deeper. Transitioning this rift pales beside the galactic giants that shouldn't exist, crashing the party of cosmic infancy. More on implications for fate. If Hubble 0 high omega, total less than 1 open universe curves, saddle-like. Dark energy equation of state, was less than -1, leads to rip. James Webb's growth factor from clusters suggests doubly equals -0.95 teetering. Case studies in coma cluster velocity dispersion implies local Hubble 0 equals 72, consistent. But Virgo in fall skews low, highlighting structure effects. Emerging tech quantum entanglement for distance, speculative, but quantum cosmology links tension to wave function collapse. James Webb's polarization data tests, spin statistics, legacy. This could be the 21st century ether hunt, disproving or reviving hidden mediums. Global collaboration. Indian Astrosat complements with ultraviolet Chinese 500-meter aperture spherical radio telescope for hydrogen-1 mapping. International unity against cosmic riddles. Artistic resonance. Sci-fi like Interstellar drew from tension, predicting warp times. Now reality catches up. In sum, the expansion crisis is our mirror to the unknown, urging bolder questions. And those questions lead straight to the universe's unruly toddlers, galaxies that grew too big too fast, defying the clock. Expanding on void models, Lemaitre-Tolman-Bondi metrics fit tension by central underdensity. James Webb's uniform high redshift distribution challenges, but edge effects possible. Simulations with illustrious TNG show 7% rate variance in voids. Regionization tie-in tension delays. Regionization, but James Webb's Lyman alpha escape fractions show early clearing mismatch, implying bursty star formation or exotic ions. Ethical science data sharing mandates ensure transparency, avoiding 20th century silos. Open source codes like Cosmo MC crunch James Webb inputs. Inspiration for youth programs like Webb's student research tie school projects to tension analysis. Future astronomers born from this. The climax, resolution or revolution by 2030 with next-gen scopes. Until then, tension tantalizes. So with expansion secrets half revealed, prepare for the galactic shockwaves that truly bend minds. Deep in the cosmic dawn, when the universe was barely 3% of its current age, just a few 100 million years after the Big Bang, the James Webb Space Telescope has uncovered something that feels like a slap from the stars themselves. 6 colossal galaxies bursting into existence, far too massive and mature for their tender years, each packing billions of stars and sprawling across space like ancient behemoths that shouldn't be there at all. These aren't your average baby galaxies, flickering weakly in the primordial soup. They are monster galaxies, nicknamed universe breakers by awestruck astronomers because they challenge the very timeline of how our cosmos cooked up its first stellar nurseries, defying the slow, gentle buildup we all thought was the rule. Imagine the early universe as a vast, foggy nursery where gas clouds clump lazily under gravity's nudge, forming pinprick stars over eons. But James Webb's infrared eyes, slicing through the murk, reveal these giants already glowing with the ferocity of modern spirals. Their light red-shifted from eons ago, showing structures so complex it as if the clock of creation was fast-forwarded in some regions, while the rest lagged behind. This discovery hit like a thunderbolt in the James Webb Advanced Deep Extragalactic Survey, or JADIS program, where teams pored over deep field images, capturing light from redshift 13.2, about 330 million years post-bang. And there they were, 6 behemoths each, weighing in at tens of billions of solar masses, dwarfing what models predicted for that epoch, when the universe's total stellar output was supposed to be a mere fraction of today's blaze. Why does this rattle cages so hard? Because standard cosmology paints a picture of hierarchical merging. Tiny dwarf galaxies nibble at each other over billions of years, building up the giants we see now like Lego blocks, stacking patiently. But these monsters suggest explosive growth right out of the gate, perhaps fueled by massive dark matter, halos collapsing in unison, sucking in pristine hydrogen, helium to ignite star formation at breakneck speeds, turning cosmic voids into stellar factories overnight. It's as if the universe played favorites, some pockets exploding into maturity, while others slumbered, hinting at uneven conditions in the post-inflation era, where quantum ripples from the Big Bang amplified into density waves that birthed these outliers. Astronomers like Priyamvada Natarajan from Yale, who helped spot these in 2025 data, called them little red dots at first due to their reddish hue from dusty interiors. But up close they reveal intricate arms and cores buzzing with activity, far beyond what cold dark matter simulations like Illustris or Eagle ever dreamed up. These models, which crunch billions of particles to mimic gravitational clumping, consistently underproduce such early heavies unless tweaked with exotic physics like warm dark matter particles that clump less diffusely, or self-interacting dark matter that scatters to allow rapid coalescence. Picture the drama in the control rooms at the Space Telescope Science Institute, where raw images flood in pixel by pixel, and suddenly these fuzzy blobs sharpen into galaxies that look suspiciously like our Milky Way, but born when Earth wouldn't even be a speck for another 12 billion years. It's exhilarating and terrifying, because if galaxies formed this fast, the entire story of cosmic evolution flips on its head. No longer a steady march from chaos to order, but a wild sprint with monsters leading the charge, perhaps seeding the supermassive black holes that later anchored galaxy centers, even influencing reionization, that era when the first stars burned off the neutral hydrogen fog, letting light propagate freely. James Webb's near-infrared camera, with its 7.7 micron sensitivity, captured these beasts in exquisite detail, showing spectral lines of oxygen and carbon that scream recent massive star births, polluting the pristine gas with metals way ahead of schedule, suggesting hypermassive population 3 stars, perhaps 100 times our sun's mass, exploding as pair instability, supernovae, to enrich the medium in a flash. This ties into the broader puzzle of cosmic dawn, where the universe transitioned from dark ages to the epoch of reionization, and these monster galaxies could be the culprits accelerating the process by flooding space with ultraviolet radiation that ionized hydrogen across vast bubbles, far quicker than planned. But how did they grow so big, so soon? One leading theory points to direct collapse, black holes forming from pristine gas clouds, collapsing without fragmentation straight into million solar mass voids that then anchor galaxy formation, pulling in more material in a feedback loop of accretion and starbirth. Another wild idea, bar instability, where bars of stars form early twisting gas, flows to funnel fuel, inward sparking bursts that double a galaxy's mass in mere tens of millions of years. It's like cosmic steroids, turning toddlers into titans. Critics argue, maybe these are not full galaxies, but proto-structures or mergers caught mid-collision. But James Webb's mid-infrared instrument peels back the dust to show coherent rotations and disks, implying stable entities, not chaotic smash-ups. In 2025 papers from the Astrophysical Journal teams analyzed over 300 such luminous objects, many define classification. Are they galaxies or something else, like active galactic nuclei? Or even population, 3-star clusters masquerading as holes. But the 6 flagships stand out for their sheer scale, challenging the Eddington limit for star formation, where radiation pressure should halt growth. Yet here they thrive, perhaps in low metallicity environments, where feedback is muted. This has ripple effects on everything, from the cosmic web's filamentary structure, where these monsters could anchor nodes pulling threads of gas and dark matter into alignment, to the global star formation rate density, which James Webb measures at higher peaks during cosmic noon around redshift 6, suggesting an earlier ramp-up driven by these early outliers. Human stories add heart to the hunt. Roberto Maiolino from Cambridge University, leading the UNR-SPEC observations, described the moment of discovery as a eureka that kept his team up for days, sifting spectra for confirmation, while graduate students like Livia Lovasolo crunched morphologies, showing disk fractions anachronistically high for the era. It's collaborative magic, with international teams from Europe, Asia, and the Americas pooling data from James Webb's General Observer programs like GUO 1595, which targeted high redshift fields, yielding terabytes of treasure. Philosophically, these monsters humble us, reminding that the universe isn't a clockwork machine, but a chaotic artist splashing creation unevenly, perhaps hinting at multiverse variations, where our bubble's laws favored rapid assembly, or even cyclic cosmology, where previous universes seeded density peaks. Alternatives abound, like modified gravity theories, where enhanced attraction in the early dense phase sped clumping, or primordial non-Gaussianities in the inflation field, imprinting lopsided potentials. But James Webb's weak lensing maps around these galaxies show dark matter distributions that lean towards standard lambda cold dark matter, with boosts from baryonic feedback. Everyday implications seem distant, yet they touch dark energy hunts, since brighter early galaxies alter luminosity, distance relations, feeding into the Hubble tension we just explored, making measurements trickier and the cosmic acceleration curve wavier. For astrobiology, these beasts suggest life-friendly conditions arose sooner, with metallicity gradients, allowing habitable zones in their outskirts, shielded from ferocious starbursts. Cultural echoes ring in sci-fi like the expansive worlds of Dune, but grounded in real data from James Webb's panoramic views, evoking awe that inspires documentaries and planetarium shows, drawing millions to ponder our place in the stellar hierarchy. Challenges persist, like foreground contamination from lensing clusters, but advanced algorithms like source extractor and Gaufit dissect the light, confirming intrinsic luminosities that scream impossibility. Future missions like the Nancy Grace Roman Space Telescope will survey wider fields to census these monsters, potentially finding thousands, while Euclid's spectroscopy adds redshifts for volume densities. The thrill builds as each cycle of James Webb observations peels more layers, revealing not just six, but families of these breakers, suggesting the early universe was a hotbed of extremes, where monsters roamed free, shaping the cosmos we inherit. Yet doubts linger: is measurement error, inflating sizes, or evolutionary models too conservative? But cross-checks with Atacama, large millimeter array, sub-millimeter maps, confirm cold gas reservoirs fueling the frenzy. Historical parallels to Hubble's galaxy classification remind us breakthroughs come from bold stares into the void, and James Webb echoes that, forging a new Hubble sequence for cosmic infancy. Emotional pull: it's wondrous to think these ancient titans lit the way for everything, including our sun, born eons later in their shadow. Inspiration flows to young minds with programs like Webb Seeds, linking school telescopes to data analysis, sparking dreams of unraveling more. The climax nears as integrated models blend hydrodynamics with machine learning to simulate these beasts, matching observations only with hybrid physics. In quiet reflection, this section of the cosmos story shows nature's audacity, defying our neat boxes and urging deeper dives. And as these monster galaxies steal the spotlight, the next revelation, wandering black holes untethered in the void, will make even these seem tame precursors to the chaos. To expand the wonder, consider how these galaxies formed in the reionization frontier, where ultraviolet photons escape to carve ionization bubbles spanning megaparsecs, with the six monsters as beacons at the heart. Their star formation rates hitting hundreds of solar masses per year, sustained by merger-driven inflows that funneled pristine gas from cosmic filaments. Spectral analysis reveals Lyman alpha emission lines piercing the neutral fog earlier than expected, implying these beasts cleared their neighborhoods swiftly, perhaps via supernova winds or black hole outflows, creating pathways for light. Theoretical frameworks like the semi-analytic models of galaxy formation predict peak masses at later epochs, but tweaking with higher initial mass functions or bursty feedback aligns with James Webb data, suggesting episodic assembly rather than steady accretion. Personal anecdotes from the field include Jane Rigby's leadership in calibration, ensuring the telescope's precision caught these subtleties, while field trips to Mauna Kea for ground-based follow-up bonded teams under starry skies. Broader ties to particle physics emerge as the rapid metal enrichment hints at heavy element production in extreme conditions, probing R-process nucleosynthesis in neutron star mergers within these galaxies. Technological marvels like James Webb's coronagraph blocking host stars to image companions reveal satellite dwarfs orbiting the monsters, hinting at hierarchical buildup, albeit accelerated. Cultural impact swells with viral videos, breaking down the finds for lay audiences, using animations of swirling gas birthing stars in fast motion. Debates rage in journals over whether these are the norm or rarities, with statistical analyses from bootstrap resampling showing they comprise 5% of high redshift populations, skewing the luminosity function upward. Future synergies with the Square Kilometer Array radio telescope will map neutral hydrogen around them, tracing inflow rates. The poetic essence lies in their defiant symbols of cosmic resilience, born in hostility to endure. Thus, weaving deeper, this monster tale primes the canvas for untethered voids devouring the narrative next. Delving into morphologies, these galaxies exhibit barred structures or spirals atypical for youth, suggesting dynamical maturity from violent relaxation after major mergers where orbital energies equilibrated swiftly. Dust attenuation curves derived from James Webb spectra show silicate features, indicating grain growth and supernovae ejecta faster than local analogs. Evolutionary tracks using stellar population synthesis codes like bagpipes fit the colors with ages under 100 million years but burst strengths triple standard values. Scientist spotlights on Masami Ochi's team from Japan University, who specialized in Lyman break galaxies, now elevated to monsters with James Webb confirmation. Data pipelines evolve with convolutional neural networks classifying over 10,000 candidates, sifting gems from gravel. interdisciplinary links to chemistry via astrochemical models, predicting complex organics in their molecular clouds, precursors to life. Public fascination grows through citizen science projects on Zooniverse, where volunteers classify James Webb images, spotting more breakers. Challenges like cosmic variance in small fields are mitigated by wide surveys like Cosmos Webb, covering diverse sightlines. Legacy building as these finds reshape textbooks, shifting emphasis from bottom-up to top-down formation in some zones. Inspirational arcs for underprivileged youth via outreach, tying urban lights to cosmic darkness. Climactic integrations with large-scale structure simulations incorporating baryonic effects to reproduce the observed clustering. Reflective pause, these monsters embody the universe's untamed youth, a ballet of extremes. Seamless flow leads to nomadic abysses echoing the wild. Analogies abound, likening the formation to flash floods in a desert, carving canyons overnight, where dark matter acts as the torrent. Quantitative insights from virial theorem applications show binding energies sufficient for stability against tidal forces in protoclusters. Case studies of individual monsters like Sears 909 revealing quasar activity, hinting symbiotic growth with central engines. Emerging paradigms and feedback models where radiation pressure regulates yet here yields to infall. Global efforts shine with Chinese contributions to data reduction via fast detections of redshifted lines. Artistic renderings and digital art contests visualize the birth pangs, inspiring creativity. Summing the saga, these galactic titans forge paths to deeper enigmas where black holes wander free, unbound by hosts. Further immersion requires exploring the dark matter halo mass function at high redshift, where James Webb gravitational lensing magnifies the beasts, revealing halos of 10 to the 12 solar masses, peaking earlier than halo occupation distribution models predict. Ionization state diagnostics from He. Two lines indicate hard spectra from massive stars, driving photoheating, that preheated gas inhibiting fragmentation for direct collapse. Historical context traces to Steidl's dropout technique, now supercharged by James Webb for secure identifications. Key metrics like specific star formation rates exceed unity, implying doubling times under gigayears, unsustainable without fresh fuel. Theoretical innovations in turbulence-regulated formation, where supersonic motions in primordial gas suppress cooling for monolithic buildup. Emotional narratives from conference hallways, where breakthroughs spark debates lasting into nights. Technological advances in adaptive optics, ground support for multi-wavelength coverage. Cultural dialogues in podcasts, dissecting implications for origin stories across faiths. Statistical rigor via Markov chain Monte Carlo, fitting to spectral energy distributions, yielding robust parameters. Future vistas with Habitable Worlds Observatory, targeting biosignatures in their descendants. Poetic closure in their light, a testament to creation's haste bridging epochs. Transition whispers of rogue devourers awaiting unveil. Numerical explorations of merger trees, using semi-numeric codes like Santa Cruz, show coalescence rates 10 times baseline for these outliers. Metallicity gradients mapped via abundance ratio. Plots reveal inside out, quenching precursors to red and dead ellipticals. Scientist journeys like those of Charlotte Mason, bridging theory and observation. Data deluge managed by cloud computing at Amazon Web Services for petascale processing. Interdisciplinary fusions with climate modeling and analogizing feedback loops. Public tools like Skyview simulators let amateurs explore the fields. Hurdles and foreground subtraction via principal component analysis yield clean signals. Enduring impact on education curricula, emphasizing discovery-driven science. Youth programs with hands-on galaxy building kits inspired by monsters. Pinnacle synthesis and unified models blending semi-analytic and hydrodynamic approaches. Contemplative end, these behemoths herald the untethered horrors to come. Vivid vignettes of the cosmic web, where filaments feed the monsters like arteries to hearts pulsing stars. Quantitative assessments of escape fractions for Lyman alpha photons approaching unity in low-dust environs. Evolutionary forecasts projecting their merger into today's clusters. Personal impacts on researchers, fostering lifelong passions. Tech feats in cryogenic deployment, ensuring detector chills for faint signals. Artistic expressions in symphonies composed for cosmic births, rigorous validations through independent teams' reproductions, prospective collaborations with lunar far-side telescopes for unobscured views, lyrical rap in their grandeur, a call to wander deeper into voids. Final threads weave halo occupation modeling refinements to accommodate the mass excess. Diagnostic tools like velocity dispersion profiles, indicating dark matter dominance. Narrative arcs from proposal to publication, spanning years of grit. Computational might in exascale simulations mirroring the frenzy. Cross-field inspirations from biology's rapid evolutions. Engagement platforms with interactive apps, simulating growth. Obstacles overcome via international accords on data sharing. Transformative role in policy funding next-gen missions. Adolescent outreach, with star parties under monster-themed skies. Culminative frameworks in grand unified cosmologies. Serene transition to black hole nomads, the next chapter's thrill. Picture a time when the universe was still a toddler, barely 600 million years old after the Big Bang, its vast emptiness punctuated by the first flickers of light. And then the James Webb Space Telescope peers through that primordial haze, spotting something utterly rogue. A supermassive black hole known as quasar. Object 1 drifting alone without a galaxy to call home. Its mass equivalent to 50 million suns, warping space-time in silent isolation, far from any stellar cradle, as if born naked into the cosmic void, defying the rule that these monsters should lurk at galactic hearts. Wanderer, Quasar Object 1 captured in 2025 observations, challenges everything we thought about black hole births, suggesting it formed through direct collapse where immense gas clouds imploded, without birthing stars, first collapsing straight into abyssal gravity, wells that then prowled the early cosmos, unchained and hungry. Imagine the shock in the control rooms at the Space Telescope Science Institute as infrared spectra revealed not just a point of darkness, but a feasting entity, accreting pristine gas, its event horizon glowing with the heat of devoured matter, hinting at chaotic origins, right from the Big Bang's turbulent wake, where density fluctuations birthed these primordial beasts, predating the first stars by eons. Primordial black holes like these could have sprung from quantum ripples in the universe's infancy. Seconds after creation, tiny singularities that ballooned through inflation, growing to stellar masses in mere moments, and then swelling further by slurping cosmic gas, their existence proposed since the 1960s, but now glimpsed by James Webb's unblinking eye as potential seeds for the supermassive titans we see today in galaxy capers. Little red dot, redshift 9, just 500 million years post-bang James Webb detected a 40 million solar mass void, its high-velocity gas signatures screaming rapid growth mechanisms that outpaced traditional stellar remnant mergers, implying these wanderers formed independently, roaming the intergalactic medium like cosmic nomads, shaping the early universe's structure before galaxies even coalesced. These black holes aren't content to sit idle. James Webb's mid-infrared instrument caught tidal disruption events, where dormant voids awaken, briefly shredding passing stars into fiery disks. The stellar spaghetti, spaghettified by tidal forces, heating up to emit infrared bursts that pierce dusty veils, revealing feasts in obscured galaxies. 4 such events, confirmed in 2025 each. A snapshot of a black hole terrorizing a wayward star, its gravity stretching the unfortunate orb into oblivion, powering flares that light up otherwise hidden realms. Unlike central engines, these wanderers suggest a dynamic early cosmos, where black holes were ejected from proto-galaxies via gravitational recoils during mergers, or formed in isolation from pristine clouds, their lack of host. Galaxies, like in a 2744 quasar object. One case where the black hole dominates a tiny metal-poor galaxy. Its oxygen abundance less than 1%, solar making it one of the most unevolved systems spotted, implying minimal star formation accompanied its rise. This low metallicity environment rules out stellar death, as a precursor no supernovae had time to forge heavier elements. So these voids must have grown from primordial seeds, bypassing the need for first-generation massive stars, collapsing into black holes and merging upward. Instead, direct infall of neutral hydrogen fueled their expansion, perhaps in dense dark matter, halos that funneled material efficiently. Astronomers like Roberto Maiolino from the University of Cambridge, who analyzed these spectra, called it a remarkable finding: massive black holes forming and growing big, without much stellar company, reshaping our view of coevolution, where black holes and galaxies grew in tandem. But here the void leads the dance, pulling in gas to ignite later starbursts. The implications ripple outward. These wandering black holes could explain the overabundance of quasars in the early universe, their bright accretion disks outshining host galaxies by factors of thousands, seeding the regionization era by blasting ultraviolet light that ionized neutral hydrogen across megaparsec scales, clearing the fog for light to travel freely. In simulations from teams like those at Maynooth University, intermediate mass primordial black holes embed in gas-rich halos, accreting swiftly to reach supermassive status within the first billion years, their growth bypassing bottlenecks like the Eddington limit through super-Eddington bursts, where radiation pressure yields to relentless infall in low-opacity environments. James Webb's near-infrared camera, with its exquisite resolution, down to arc-seconds, pinpoints these rogues in deep fields, like the Cosmic Evolution Survey, uncovering over 300 luminous red dots, many harboring central voids, but some like quasar object. One fully detached their spectra, showing broad emission lines of carbon and nitrogen from heated gas, devoid of iron lines that would betray stellar pollution. Personal stories from the hunt add flavor. Lead author Louis Prohl recalled the eureka moment when models aligned with James Webb data, confirming primordial seeds could swell to 10,000 solar masses in 100 million years. A blink in cosmic time while graduate students pored over petabytes, crunching Markov chain Monte Carlo fits to spectral energy distributions, yielding masses with 1% precision. Philosophically, these nomads evoke a wilder universe, not the orderly assembly line of hierarchical merging, but a frontier lawless, with black holes as outlaws carving paths through the void, perhaps even implanting in dwarf galaxies to anchor their cores, or colliding to forge even larger beasts in intergalactic space. Cultural echoes resound in science fiction, like rogue singularities in event horizons, but grounded in James Webb's empirical gaze, which spotted a naked black hole, 50 million suns, strong, rewriting cosmic history as a tale of untethered monsters born from the Big Bang's fury. Challenges in detection abound: foreground dust and lensing distortions, but advanced algorithms, like those using convolutional neural networks, sift signals from noise, confirming the wanderer's reality, while cross-checks with Atacama, large millimeter array, sub-millimeter maps reveal cold gas tails, trailing these voids, like cosmic contrails, 20,000 light-years long, narrow, at 650 light-years wide, scars from plowing through gas clouds. Future synergies with the Nancy Grace Roman Space Telescope's wide surveys will census these roamers, potentially finding thousands, while Euclid's spectroscopy maps their redshifts for density, estimates the square kilometer array radio telescope, tracing neutral hydrogen inflows, fueling their wanderlust. The thrill intensifies as James Webb's Cycle 3 programs target high redshift fields, unearthing more like LID 568, a supermassive black hole at 11%, cosmic age growing rapidly through feast after feast, its light curve showing bursts that outpace steady accretion models. Everyday ties seem esoteric, yet these discoveries feed into dark matter hunts, as primordial black holes could comprise a fraction of the unseen mass, their microlensing effects probed by Gaia data releases. For astrobiology, wandering voids suggest hazardous zones where tidal forces shred planets, but also forge heavy elements via kilinovae and neutron star companions, enriching future habitable worlds. Debates flare in journals over formation channels, with some favoring direct collapse in atomic cooling. Halos, where gas cools via Lyman alpha, transitions to collapse monolithically. Others primordial from inflation era over densities, their evaporation via Hawking radiation negligible for supermassive scales. Statistical analyses bootstrap resampling of James Webb catalogs show these wanderers comprise up to 5% of early luminous sources, skewing the black hole mass function upward at high redshifts. Inspirational arcs for youth via Webb Seeds programs link school projects to analyzing light curves, spotting disruption, flares fostering the next generation of cosmic detectives. Legacy builds as these finds reshape textbooks emphasizing top-down black hole dominance in cosmic infancy over bottom-up stellar paths. Emotional pull, it's humbling to glimpse these ancient predators eternal, since creation roaming the expanse, shaping destinies unseen. Seamless flow leads to cosmic collisions where suspended voids in merging galaxies amplify the chaos. To deepen the narrative, consider the mechanics of ejection three-body interactions. During galaxy mergers, sling black holes outward at thousands of kilometers per second, their velocities, measured by James Webb's integral field units, revealing proper motions in quasar pairs. Quantitative insights from virial theorem show binding energies insufficient for retention in low-mass hosts, leading to ejections, while general relativity's no-hair theorem implies their simplicity, pure gravity, without accretion disks, in dormant phases. Case studies, like the Rogue and Fangs field, where a million solar mass black hole orbits far from center, its tidal event captured mid-spaghettification. Emerging paradigms in feedback, where wandering voids quench star formation and host dwarfs by heating gas outflows. Global collaborations shine with European Southern Observatory ground support, complementing James Webb's Space Vantage. Artistic renderings in digital planetariums visualize the Rome visualizing event horizons as swirling maws devouring stars. Rigorous validations through independent teams confirm masses via reverberation mapping of broad lines. Perspective, with Habitable Worlds Observatory, targeting infrared echoes from ancient feasts, lyrical in their isolation symbols of cosmic independence. Transition to infinity galaxies suspended black hole, the next unbound wonder. Numerical explorations of growth rates show exponential phases reaching Eddington 40 times over in bursts sustained by clumpy accretion. Metallicity diagnostics from forbidden lines reveal pristine origins with carbon over oxygen ratios hinting Big Bang nucleosynthesis ties. Scientist journeys like Megan Masterson's at Massachusetts Institute of Technology, bridging infrared transients to void hunts. Data deluge managed by high-performance computing clusters processing 20 gigabytes daily. Cross-field with quantum gravity probing singularity resolutions. Engagement via interactive simulations letting users steer virtual wanderers. Obstacles in redshift determination via Bayesian inference yield precise distances. Transformative for policy boosting funding for infrared missions. Outreach with star parties themed on cosmic nomads. Culminative and grand theories blending primordial cosmology with black hole thermodynamics. Serene end, these voids whisper of deeper collisions awaiting. Vivid of the event horizon's sway, where time dilates for infalling matter, photons orbit at photon spheres. Quantitative escape fractions for ionizing radiation approach unity, aiding regionization. Evolutionary forecasts project mergers into today's quasars. Personal impacts, fostering awe in researchers. Tech in cryogenic sensors detecting faint mid-infrared glows. Artistic symphonies for black hole serenades. Validations via multi-wavelength campaigns. Collaborations with lunar telescopes for baseline extensions. Rapid grandeur calls to explore suspended abysses, threads of halo interactions, where wanderers seed structure, diagnostics of spin via iron lines, indicating coalescence histories, narrative from detection to interpretation, spanning collaborations, computational and gadget codes, simulating ejections, inspirations from ecology's rogue predators, platforms with virtual reality tours of voids, overcome via open data portals, role in education sparking cosmology clubs, youth with model kits of spaghettification, frameworks unifying direct collapse and primordial. Pause, these nomads herald infinity's drama, analogies to oceanic drifters, currents carrying them afar, assessments of microlensing events, probing dark matter fraction, studies of individual like a 2744 quasar object, one's low metallicity feast, paradigms in super Eddington physics, efforts with Indian giant Metrovave radio telescope for radio counterparts, expressions in literature of eternal voids, fitting to light curves with Gaussian processes, vistas with Lynx X-ray mission for accretion details, closure in their mystery bridges, to merging fates, explorations of pair instabilities, in seed formation, plots of mass functions peaking early, arcs of Priyamvada Natarajan's theoretical bridges, might in exascale for full hydroevolutions, fusions with chemistry of accretion disks, tools for citizen spotting of transients, subtraction of host light via PSF fitting, impact on curricula with void modules, programs hands-on with infrared demos, syntheses hydrodynamic and semi-analytic, and these wanderers ignite the collision chapter's fire. Imagine the universe's early days, not as a serene cradle of stars, but as a brutal arena where two colossal galaxies smashed together in a cosmic car crash, their spiral arms twisting into a hypnotic infinity loop, leaving a supermassive black hole dangling precariously in the void between them, like a gravitational tightrope walker caught mid-fall. This is the Infinity Galaxy, a jaw-dropping discovery from the James Webb Space Telescope's infrared gaze, peering back 13 billion light-years to when the cosmos was just a toddler about 500 million years old, its light stretched into the red end of the spectrum by the relentless expansion, showing two massive structures, one dwarf, the other, a behemoth, colliding headlong in a dance of destruction and creation. Picture the scene: gas clouds the size of entire star systems funneled into the collision zone, collapsing not into stars, but directly into this suspended black hole, a process called direct gas collapse, where immense pressures and densities squeeze the pristine hydrogen straight into an abyssal gravity, well without the messy middle step of stellar births. This void weighs in at over 100 million times our sun's mass. Its event horizon, a one-way trap for light and matter, hovering equidistant from the merging galaxy's cores, warped spacetime rippling like a pond, disturbed by an unseen stone. The James Webb's near-infrared camera captured the chaos in exquisite detail, spectral lines of hot, ionized gas screaming from the accretion disk as it feasts on the debris, turning the collision into a fireworks show of X-rays and ultraviolet blasts that could outshine entire galaxies. This isn't just a smash-up, it's a gravitational instability on steroids. The two galaxies' dark matter halos intermingling like invisible ghosts pulling strings behind the visible spectacle, creating tidal tales of stars and gas stretching thousands of light-years long, like cosmic scarves fluttering in the intergalactic wind. The suspended black hole acts as a pivot point, its immense pull slinging material from one galaxy to the other, fueling bursts of star formation in the wreckage where new suns ignite in the debris clouds, 10 times brighter than anything in our Milky Way today. Astronomers dubbed it the Infinity Galaxy for the way the colliding arms loop eternally in long exposure, images a visual echo of mathematical infinities, but grounded in the brutal physics of general relativity, where velocities near light speed stretch space itself into warped geometries. The drama unfolds in slow motion across eons. The collision began when the universe was a mere fraction of its current age, the dwarf galaxy plowing into the larger one's outskirts at hundreds of kilometers per second, triggering shock waves that compress gas into dense knots, sparking supernova chains that enrich the medium with heavier elements like carbon and oxygen, paving the way for future planetary systems in the merger's wake. James Webb's mid-infrared instrument peeled back the dust veils to reveal the black hole's isolation. No surrounding stars or gas to anchor it, suggesting it formed in the cold, pristine clouds between the galaxies, a rare event where the universe's first heavy elements were scarce, allowing the collapse to proceed unimpeded, without stellar feedback. Halting the infall, this direct collapse mechanism solves puzzles about how supermassive black holes grew so large so fast in the early cosmos, bypassing the slow merger of smaller stellar remnants, which would take billions of years instead. These voids bloomed from gas alone, reaching critical mass in mere millions of years, their growth then accelerated by the collision's bounty, slurping dual streams of fuel from both galaxies like a thief in the night. Human elements bring the discovery to life teams at the European Southern Observatory, and NASA's Goddard pored over the data for months with lead researcher Elena Visbal from Princeton, describing the moment the spectra aligned as a heart-pounding revelation that kept the room silent for minutes. The black hole's position precisely calculated at the Lagrange point between the galaxies, where gravitational forces balance in a delicate equilibrium. Any perturbation could send it tumbling into one core or the other. But for now, it reigns supreme, its hawking radiation a faint theoretical whisper negligible at such scales. The accretion rate super Eddington by factors of 10, where the inward pull overwhelms radiation pressure, allowing unchecked growth. The infinity galaxy's instability creates ripples across the cosmic web, nearby filaments of dark matter and gas disturbed into new formations, potentially seeding clusters of galaxies in the future, a domino effect of collisions that shape the large-scale structure we see today. Philosophically, this spectacle questions our tidy models of cosmic order. Is the universe a harmonious symphony or a chaotic brawl where collisions forge the future? From wreckage hinting at black hole cosmology, where our entire cosmos might be the interior of a larger black hole with event horizons as boundaries and singularities as big bangs. The suspended void in infinity galaxy, a microcosm of that grander turmoil. Transitioning to even wilder revelations, James Webb's deep field surveys uncovered something even more profound: galaxies across billions of light years, rotating in eerie synchronized patterns, their spin axes aligned, as if the whole universe was born twirling like a cosmic ballerina. This isn't random chance, but a coordinated whirl, suggesting the cosmos inherited angular momentum from its birth. Perhaps the remnant of a parent universe, the spin of a primordial black hole that birthed ours through evaporation or collapse. The data from over 500 galaxies at redshifts up to 10 shows clockwise spins, dominating in one cosmic hemisphere counterclockwise. In the other, a dipole asymmetry that defies the isotropic Big Bang model, where rotations should average to zero. Imagine the implications: the universe spinning on vast scales would generate frame-dragging effects, twisting spacetime in ways that influence galaxy formation and dark energy distribution. James Webb's integral field spectroscopy measured rotation curves, revealing barred structures and spiral arms, all pointing in preferred directions, as if guided by an invisible hand. This could explain the cosmic microwave background's cold spot anomalies, or the alignment of quasar jets pointing along great circles, a cosmic conspiracy of motion that hints our observable universe is but a slice of a rotating multiverse. The synchronized spins tie back to inflation theory, where quantum fluctuations in the inflaton field carried vorticity, amplified by expansion into macroscopic rotations. But standard models predict isotropy, yet James Webb data shows a net spin parameter of about 10% deviation, challenging the cosmological principle that the universe looks the same in all directions. Perhaps we're in a bubble where local conditions favored spin, or more radically, the universe as black hole interior would inherit its parent's rotation, explaining dark matter as angular debris and expansion as evaporative growth. Astronomers like Lear Shamir, who pioneered spin studies, called the 2025 findings paradigm-shattering with statistical significance. At 5 sigma, the odds of chance alignment, 1 in 3.5 million. The patterns persist across scales from dwarf galaxies to clusters, suggesting a universal handedness that could solve the baryon asymmetry problem. Why matter dominates antimatter? Perhaps spin sorted them in the early plasma. This spinning cosmos evokes vertigo, our home galaxy, the Milky Way twirling at 230 kilometers per second. Around its core, now part of a larger ballet, where collisions like infinity galaxy accelerate the dance, flinging stars into intergalactic space, while black holes merge in gravitational wave chirps, detectable by future space-based lasers like LISA. Cultural resonance strikes in ancient myths of cosmic wheels, from Hindu Kalashakra to Norse Ymir's spinning creation, but now empirically glimpsed through James Webb's Golden Mirror, the telescope's sunshield deployed to block Earth's glare, allowing infrared views of this rotational ballet. Challenges in measurement include projection effects, where line of sight tilts mimic alignments, but machine learning classifiers, trained on simulations, confirm the bias with 95% confidence. Cross-checks with Hubble's archives show the pattern emerging stronger in deeper infrared. Future missions like the Roman Space Telescope will map spins in 3 dimensions via weak lensing shear fields, while Euclid's galaxy clustering data tests spin dark matter interactions. The Square Kilometer Array, radio mapping neutral gas rotations to trace the vorticity back to cosmic dawn. The emotional thrill of these collisions and spins lies in their revelation of a dynamic, alive universe, not static, but perpetually in motion. Infinity, galaxies' suspended black hole, a frozen moment in eternal flux. The synchronized worlds, a cosmic choreography that binds distant realms. Inspirational for youth Webb-inspired programs. Let students model collisions in virtual reality, simulating gravitational slingshots and spin inheritance, fostering wonder about our place in the turn. Legacy redefines textbooks, shifting from uniform expansion to rotational dynamics, with implications for time's arrow. Why the universe spins forward, perhaps entropy's hand in the world. Poetic in their grandeur, these cosmic collisions and spins weave a tapestry of motion, leading seamlessly to rogue worlds whose cries echo the chaos. To deepen the immersion, consider the numerical dance of the infinity galaxy. The relative velocity of the dwarf intruder, about 400 kilometers per second, computed from Doppler shifts in emission lines. The black hole's mass, derived from broad line region. Reverberation mapping with a lag of weeks in response to continuum changes, indicating a light travel time across the disk. Quantitative spin alignments show a preferred axis tilted 30 degrees from the cosmic microwave background dipole, suggesting local influences like great attractor flows, but persisting globally. Case studies like the Mice Galaxies, a classic merger now joined by infinity, as a high redshift analog, its tails analyzed for star cluster formation rates exceeding 100 per mega-year. Emerging theories in vorticity transport, where magnetic fields from primordial plasma seed, the spins amplified by merger torques. Global efforts with Japanese Subaru telescope, providing ground truths for James Webb space views. Artistic digital twins simulate the collision in 4 dimensions time, as the fourth allowing viewers to orbit the suspended void. Rigorous fitting to N-body simulations yields merger timescales of 100 million years post-pericenter. Perspective with James Webb's next cycle, targeting spin quasars for jet alignments. Lyrical, the whirl binds infinities in eternal dance. Threads of general relativistic frame dragging, where rotating black holes and mergers drag the fabric, influencing spin inheritance. Diagnostics of ram pressure, stripping and colliding gas revealing bow shocks at Mach 5. Narrative from proposal to press release, a year of intense scrutiny. Computational might-in, or repo codes, resolving gas dynamics at parsec scales. Fusions with fluid dynamics, analogies of turbulent mergers. Platforms interactive with zoomable infinity maps. Overcome via calibration campaigns for spectrograph stability. Role in sparking interdisciplinary art science festivals. Youth, hands-on with spin toys modeling cosmic tops. Frameworks blending hydro and N-body for full evolution. Pause the motion heralds rogue cries next. Analogies to terrestrial collisions like the Chicxulub impact. Scaled to galactic realms forging new worlds from old. Assessments of dynamical friction slowing the intruder over giga-years. Studies individual arms showing age gradients, young stars at tips. Paradigms in feedback quenching post-merger. Efforts with Chinese fast for hydrogen mapping entails. Expressions in poetry of infinite loops. Fitting to light curves with spline interpolation. Vistas links for X-ray binaries and debris. Closure spins and smashes bridge to wandering worlds. Explorations of binary black hole spins in the suspended core. Plots of angular momentum conservation across the merger. Arcs of team collaborations across continents. Might in petascale for million particle runs. Inspirations from dance choreography of cosmic ballets. Tools for public simulation runners. Subtraction of foreground lenses via ray tracing. Impact on philosophy of rotational time. Programs with observatory visits to witness analogs. Syntheses and unified rotation merger models. End the collisions propel toward atmospheric enigmas. Vivid of the gravitational waves rippling from the black hole's wobble. Quantitative ionization bubbles from merger UV floods. Forecasts of descendant ellipticals post-coalescence. Personal fostering global scientific bonds. Tech and deployable mirrors for deep field stability. Artistic murals of spinning infinities. Validations multi-mission overlays. Collaborations with Antarctic telescopes for infrared clarity. Wrap and whirl calls to rogue signals. Numerical of halo spin parameters lambda greater than 0.1 for aligned systems. Plots of dipole moments in spin vectors. Arc's narrative of discovery eureka. Might exascale for vorticity fields. Fusion's ecology of predator-prey and mergers. Platforms VR of collision fly-throughs. Overcome data overload with AI triage. Role education spin experiments. Youth kits building galaxy models. Frameworks grand spinning cosmologies. Serene the dance leads to planetary wanderers. Analogies. Oceanic collisions merging currents. Assessments lensing magnifications of spin signals. Studies tales for globular cluster ejection. Paradigms. Super Eddington and merger bursts. Efforts Indian Astrosat UV follow-up. Expressions symphonic scores for cosmic crashes. Fitting Bayesian to parameter spaces. Vistas with sphere for exoplanets and debris. Closure infinities. Spin to rogue atmospheres. Explorations direct imaging of the suspended horizon. Plots merger rates. Peaking at redshift 3. Arc's personal perseverance and analysis. Computational quantum for wave functions and spins. Inspirations mythology wheels of fate. Tools citizen classification of mergers. Subtraction host galaxy light. Impact cultural cosmic art. Program school telescopes for local analogs. Syntheses full physics simulations. End collisions ignite rogue world wonders. Vivid merger fireworks outshining quasars. Quantitative star formation efficiency. 30% in shocks. Forecasts cluster formation timelines. Personal team celebrations. Tech cryodetectors for faint spins. Artistic animations viral on social. Validations independent reductions. Collaborations, international data hubs, wrap grandeur to binary rogues, threads vorticity from inflation seeds, diagnostics magnetic fields in gas bridges, narrative year-long verification, might hybrid CPU-KPU clusters, fusions climate models of turbulent flows, platforms app-based spin quizzes, overcome resolution limits with deconvolution, role-inspiring STEM careers, youth workshops on galaxy building, frameworks rotational lambda, cold, dark matter, pause spins herald atmospheric mysteries, analogies ballet of gravitational tango, assessment statistical isotropy tests, studies individual synchronized pairs, paradigms universe as Kerr black hole interior, efforts Australian square kilometer array pathfinder precursor, expressions literary odysseys and whirl, fitting maximum likelihood to alignments, vistas post James Webb, spin surveys, closure cosmic dance, to planetary cries, explorations spin dark energy coupling, plots hemispheric spin fractions, arcs discovery timeline milestones, might neural networks for pattern recognition, inspirations ancient cosmogonies, tools open source spin catalogs, subtraction projection biases, impact philosophical isotropy debates, programs virtual reality cosmic tours, syntheses spin merger evolution, end the world propels rogue worlds into view. Venture into the shadowy edges of the Orion Nebula, where the James Webb Space Telescope has unveiled over 500 rogue planets, floating free from any star's embrace. These cosmic orphans drifting through the interstellar chill, many locked in eerie binary pairs, orbiting each other in a solitary tango, their surfaces scarred by radiation and isolation, yet emitting powerful gigahertz radio bursts that scream across the void like distress, calls from the universe's forgotten children. Picture these wanderers, each about the size of Jupiter, but colder than liquid nitrogen, ejected from their birth clusters during the chaotic youth of star formation, where gravitational tussles slung them outward into the abyss. James Webb's mid-infrared instrument captured their faint heat signatures in 2025 observations, revealing binary systems where two rogue planets circle a common center of mass, separated by mere millions of kilometers, their magnetic fields tangled in a deadly embrace, generating auroral lights that flicker in radio waves 10 times stronger than Jupiter's own stormy broadcasts, suggesting orbital interactions whip up plasma storms powerful enough to rival our sun's solar flares. This isn't mere solitude. It's a defiance of planetary norms. These rogues challenge the idea that worlds need stellar parents for warmth and stability, instead thriving on internal heat from formation contractions and tidal heating between pairs, where friction from their dance melts rocky cores into molten seas. The James Webb's near-infrared camera spotted over 50 such pairs in the Orion's trapped star-forming region, their temperatures hovering around -200 degrees Celsius. Yet the radio signals imply colossal dynamos, deep within metallic hydrogen layers, churning under immense pressures, creating fields 1,000 times Earth's magnetic shield. Astronomers like Mark Swizdak from the University of Maryland, who analyzed the data, described the discovery as a revelation of the universe's underbelly, where these binaries could be common relics of violent cluster ejections, their signals detected by the Very Large Array Radio Telescope in tandem with James Webb, confirming the bursts originate from electron-cyclotron masers in the polar caps, where charged particles spiral along field lines, emitting coherent radiation that pierces the cosmic dust. This hints at a hidden population of free floaters numbering in the billions across the galaxy, potentially outnumbering bound planets and reshaping estimates of habitable worlds, as these rogues might harbor subsurface oceans warmed by tidal forces or radioactive decay, making them oases in the cold. Transitioning from these radio-crying duos to even fiercer extremes, imagine the hellish exoplanet 55 Cancri E, a super-Earth orbiting its star so closely that dayside temperatures soar to 2,400 degrees Celsius. Its atmosphere not gas but vaporized rock, a global magma ocean, evaporating into silicate clouds that rain molten droplets across the tidally locked surface. James Webb's 2025 spectra pierced the glare, revealing carbon dioxide and carbon monoxide dominance in the haze, with no water vapor in sight, suggesting the intense stellar radiation boiled away oceans, if they ever existed, leaving a hellscape where winds howl at 5,000 kilometers per hour, carrying bits of evaporated lava in a perpetual storm. The planet's mass 8 times Earth's and radius, twice that yields surface gravity, twice as strong, trapping the vaporous envelope, despite the heat that should strip it away. But volcanic outgassing from a restless mantle replenishes the air with sulfur and silicates, creating a dynamic equilibrium where the atmosphere glows in infrared like a forge in the night. This vaporized world defies habitability, norms its proximity to the star just one day of travel away, bathes it in ultraviolet fury. Yet James Webb's high-resolution imaging showed asymmetric heat distribution, with the night side cooler, but still molten thanks to heat transport by super-rotating winds that circulate the atmosphere in mere hours. The data from the mid-infrared instrument indicated atmospheric pressures 10 times Earth, squishing the gases into dense layers, where rock vapor condenses into droplets, heavy enough to fall as fiery rain, etching craters and fueling more eruptions in a self-sustaining inferno. Astronomers like Niku Madhusudan from Cambridge University called it a laboratory for extreme geology, where the planet's iron core generates a dynamo field, shielding the air somewhat from stellar winds. But the real shocker is the potential for diamond rains, as carbon under pressure crystallizes in the depths, raining upward in a bizarre convection cycle. The implications ripple outward. 55 Concred E suggests a class of lava worlds, common around red dwarfs, where close orbits bake planets into volcanic behemoths. Their atmospheres, rich in refractory elements like silicates and metals that could forge exotic minerals unseen on Earth, challenging models of planetary evolution and hinting at the diversity of rocky worlds beyond our solar system. James Webb's observations ruled out hydrogen envelopes, confirming the rocky vapor composition, with spectral lines of silicon oxide matching lab simulations of rock evaporation. At those temperatures, the planet's density points to a composition 40% iron, the rest silicates and carbon, turning it into a supersized version of Venus, but amplified to apocalyptic scales. Now zoom to the ultimate rogue wanderer, the free-floating planet, simple 0136 plus 0933, a gas giant 13 times Jupiter's mass, orbiting nothing but the galaxies, pull its atmosphere. A toxic brew of layered iron and magnesium clouds, where iron vapor condenses into droplets that plummet as red-hot rain across the stormy depths, powered by a magnetic field 200 times stronger than Jupiter's, generating radio auroras that light up the interstellar dark. James Webb's 2025 infrared spectra revealed the metallic haze, with temperatures around 2,000 degrees Kelvin at the topmost layers, cooling to 1,000 degrees lower down, where silicates form hazy veils. The planet's isolation amplifies its internal heat from gravitational contraction during formation, now sustained by the auroral heating from its own field, interacting with cosmic rays and interstellar plasma, creating polar lights visible in radio and X-rays. Metal cloud drifter defies planetary norms as a brown dwarf borderline object, too massive for a planet, yet not fusing hydrogen. Its youth, estimated at 20 million years, keeps it hot and glowing. The iron rain cycles through convection, lifting vapor from the deep ocean of molten metal below, where pressures crush atoms into exotic states. The James Webb's data showed spectral absorption from vaporized sodium and potassium, adding to the toxic palette. while the radio emissions detected by the low-frequency array indicate cyclotron radiation from electrons trapped in the field lines, suggesting a dynamo driven by differential rotation in the convective layers. This rogue's path through the galaxy, estimated speed 50 kilometers per second, could lead it through dense clouds, stirring up more auroras, or even accreting stray gas to grow its envelope. Human stories behind the hunt add intimacy. The Discovery team, led by Caitlin Allers from Bucknell University, spent years correlating James Webb's images with ground-based radio detections. The eureka moment coming when spectra aligned with models of metallic atmospheres, confirming the iron rain, a process theorized since the 1990s, but now observed in a free floater. The planet's spin period of about 10 hours whips up the winds, fueling the layered clouds, where iron droplets evaporate and reform in a continuous cycle, potentially lasting billions of years, unless a passing star claims it. Philosophically, these rogue worlds and atmospheres paint a universe teeming with outcasts, from binary screamers to lava infernos, and metal-raining ghosts, suggesting life's building blocks might form in such extremes, where carbon compounds in 55 Cancre's haze could seed organic chemistry, or subsurface habitats on the rogues, warmed by internal fires, challenging our star-centric view of habitability. Cultural echoes in sci-fi like Rogue Planets and Interstellar find empirical roots in James Webb's gaze, inspiring documentaries that blend data with wonder, while challenges like faint signals amid stellar glare are overcome by advanced coronagraphs, blocking host light for clearer views. Future missions like the Aerial Space Telescope will probe thousands of atmospheres for biosignatures. Even on rogues, via flyby surveys the Habitable Worlds Observatory. Targeting subsurface oceans, the emotional pull is profound. These worlds remind us of resilience and isolation, their cries and vapors a symphony of the cosmos's wild side. Inspirational programs like Webb Seeds engage students in classifying rogue candidates, fostering the next explorer's legacy, redefines planetary science, emphasizing the unbound majority. Poetic in their freedom, these rogues and hells weave to mysterious lights. Next, to immerse deeper in the Orion rogues, the binary pairs show orbital periods from days to years, with separations allowing tidal locking where one face of each planet perpetually views the other. Heating it asymmetrically, the radio bursts modulated by these orbits, peaking at conjunctions when fields align for maximum interaction. James Webb's imaging resolved the pairs at 100 astronomical units apart, their masses around 5 Jupiter masses, each yielding low densities, implying hydrogen-helium envelopes polluted by meteoric impacts. The signal's polarization indicates left-handed chirality. From field configurations suggesting dynamo asymmetries, case studies like one pair dubbed the twins showed synchronized auroras like a cosmic light show the quantitative flux density at 1 GHz, reaching 1 microjansky beaming across light years. Emerging theories in ejection dynamics, where 3-body interactions in clusters favor binary ejection over singles, preserving the pair's isolation. Global teams with European Space Agency's Euclid, providing wide field context. Artistic visualizations in 3D, renders of iron rain on simple 0136. Rigorous modeling, with general circulation codes, simulating winds at Mach 1. Perspective, with James Webb, Cycle 4 targeting rogue transits. Lyrical vapors and bursts, call to luminous enigmas. Threads of migration, where rogues perturb local stars. Diagnostics of helium absorption in spectra, indicating young ages. Narrative from proposal to publication. Collaborative grit, computational and planet formation codes, like Burn for binary evolution. Fusions with atmospheric chemistry of rain cycles. Platforms interactive rogue trackers. Overcome noise with adaptive filtering. Role in education planetary diversity modules. Youth workshops. Building model rogues. Frameworks unbound planet demographics. Pause the world's lead to light mysteries. Analogies to earthly orphans. surviving harsh climes. Assessment statistical excess of binaries and ejections. Studies individual radio light curves. Paradigms tidal heating for habitability. Efforts with Canadian hydrogen intensity mapping experiment for gas interactions. Expressions poetic of solitary dances. Fitting phase curves with sinusoidal models. Vistas with twinkle for mid-infrared spectra. Closure rogues to red dots. Explorations of auroral electron precipitation rates. Plots mass radius for brown dwarf boundaries. ARC's team discoveries at conferences. Might GPU accelerated for atmospheric sims. Inspirations mythology of lone wanderers. Tools citizen science for signal hunting. Subtraction stellar contamination. Impact cultural sci-fi realism. Program school observatories for Orion views. Syntheses ejection and evolution models. End the vapors propel to chemistry wonders. Vivid of lava flows on 55 Cancri E. Quantitative outgassing rates from mantle convection. Forecasts atmospheric stability over giga-years. Personal researcher passions ignited. Tech in spectrograph precision for faint lines. Artistic murals of metal rains. Validations multi-wavelength confirmations. Collaborations international databases. Wrap isolation to luminous fates. Numerical of field strengths from Faraday rotation. Plots burst durations versus orbital phase. ARC's narrative eureka moments. Might neural nets for classification. Fusions geology of vapor worlds. Platforms VR tours of rogues. Overcome distance with microlensing. Role inspiring exoplanet hunters. Youth kits for atmosphere demos. Frameworks rogue formation theories. Serene the cries bridge to lights. Analogies oceanic twins and currents. Assessments population synthesis models. Studies vapor condensation altitudes. Paradigms super-Earth hells as norms. Efforts Australian Telescope National Facility Radio follow-up. Expressions symphonic for radio screams. Fitting dynamical models to pairs. Vistas post-James Webb. Rogue censuses. Closure worlds to chemical dawns. Explorations biosignature hunts on subsurface. Plots spectral indices for metallic hazes. ARC's collaborative breakthroughs. Computational exascale for global circulations. Inspirations ancient sky myths. Tools open data for public analysis. Subtraction foreground dust. Impact philosophical habitability. Programs virtual planet labs. Syntheses atmospheric and dynamical. End rogues illuminate mysterious lights. Vivid binary eclipses in radio. Quantitative dynamo efficiency 70%. Forecasts rogue clusterings. Personal team bonds. Tech cryo-optics for cold detections. Artistic animations of iron storms. Validations independent spectra. Collaborations global archives. Wrap hells to early elements. Threads migration paths through galaxy. Diagnostics water absence in spectra. Narrative year of analysis. Might A for anomaly detection. Fusions climate analogies. Platforms app simulations. Overcome resolution with interferometry. Role stem diversity. Youth stargazing rogue hunts. Frameworks lava world classifications. Pause atmospheres herald chemistry. Analogies volcanic earth. Scaled up. Assessments eruption frequencies. Studies raindrop sizes in iron clouds. Paradigms free floater dynamos. Efforts Chinese fast for low frequency. Expressions literary toxic skies. Fitting thermal profiles. Vistas aerial for exosphere probes. Closure vapors to red luminosities. Explorations tidal lock effects on weather. Plots temperature gradients. ARC's discovery timelines. Might petascale for pair evolutions. Inspirations folklore wanderers. Tools ZTF for transient rogues. Subtraction interstellar medium. Impact art-inspired science. Programs observatory partnerships. Syntheses rogue and bound comparisons. End the world's secrets lead to light enigmas. Deep in the cosmic dawn, when the universe was a mere 330 million years old, the James Webb Space Telescope has pierced the veil to reveal over 300 mysterious little red dots, twinkling anomalously bright in the early skies like forbidden embers that shouldn't flicker so. Fiercely each a compact source of infrared glow, defying easy classification as supermassive black holes voraciously feeding on gas, or perhaps entirely novel cosmic entities born from the Big Bang's aftershocks. Their light stretched across 13 billion light-years to reach us today, showing luminosities thousands of times brighter than entire galaxies, at that tender epoch suggesting rapid formation mechanisms that outpace our models of stellar or void growth. These red dots, spotted in the James Webb's Cosmic Evolution Survey, deep fields, appear as tiny crimson specks against the black canvas, their spectra bursting with broad emission lines of ionized carbon and nitrogen, indicating hot, dense environments where gas orbits at near-light speeds spiraling into event horizons or exotic cores. The 2025 data from the near-infrared spectrograph revealed over 100 confirmed examples at redshift, greater than 7 each compact, to within mere parsecs, yet radiating energy equivalent to 1 trillion suns. The puzzle lies in their origin standard. Theories demand gradual buildup from stellar remnants, merging in clusters, but these dots hint at direct gas collapse or primordial seeds inflating during the universe's rapid expansion phase, where quantum fluctuations coalesced into dense pockets that lit up without stars. The little red dots challenge the timeline of cosmic illumination, potentially explaining the overproduction of quasars in the first billion years, as these enigmas seeded active galactic nuclei that blazed the path for reionization. Imagine the astonishment in the analysis rooms at the Space Telescope Science Institute, where astronomers like Ryan Ensley from the University of Texas pored over the pixels, the first spectra popping up like fireworks, confirming not just brightness, but chemical signatures of low metallicity, pristine gas, untouched by starlight, suggesting they formed before heavy elements could form the red hue from dust obscuration or redshifted ultraviolet light. But peeling back the layers with James Webb's mid-infrared instrument uncovered hidden structures, perhaps tiny galaxies in formation, or black hole binaries, colliding in a gravitational tango, their energy output straining the Eddington limit, where radiation should blow away in falling material, yet here it thrives,
implying super efficient
accretion in low opacity media. The implications stretch to the cosmic web,
ways dots could anchor early filaments, pulling neutral fluid.
expected for that age, transitioning from these luminous riddles to even more baffling chemistry. The James Webb's gaze on primordial galaxies has uncovered young stars forging heavy elements like oxygen and carbon, far earlier than any model predicted. When the universe was less than 2% of its current age, just about 200 million years post-Big Bang, spectral lines in galaxies like Jade's deep field targets show enrichment levels comparable to today's Milky Way, with oxygen abundances at 10% solar, yet without generations of supernovae to seed the gas. This suggests hypermassive first-generation stars known as population. 3 objects, weighing up to 300 solar masses, exploding in pair instability. Supernovae that ejected vast amounts of metals in single cataclysmic blasts. Skipping the slow cycle of stellar evolution, the 2025 observations from the Integral Field Unit revealed broad emission lines of neon and magnesium in these ancient systems, indicating nucleosynthesis in extreme conditions where core temperatures exceeded 10 billion degrees Kelvin, fusing silicon to iron in a flash. The puzzle deepens as the metals appear uniformly distributed across the galaxies, not clumped near star-forming regions, implying rapid mixing via supernova winds or galactic winds that disperse the ejecta across megaparsec scales, challenging the idea of patchy enrichment in the early universe. These precocious heavy elements rewrite the story of cosmic cooking, where the Big Bang left mostly hydrogen and helium. The first stars were supposed to gradually pollute the medium, but James Webb data from over 50 such galaxies shows carbon monoxide and water vapor in molecular clouds around protostars at redshift 10, suggesting the metal factories ignited almost immediately after the Dark Ages ended. Astronomers like Andrew Bunker from the University of Oxford described the findings as a time machine to the universe's kitchen, where the recipe for complexity started with a bang, not a simmer. The oxygen came not from core collapse, supernovae of ordinary stars, but from these giants that self-destructed before forming neutron stars, leaving no remnants, just clouds of enriched gas that collapsed into the next wave of stars, accelerating the buildup of rocky planets and life-enabling chemistry across the cosmos. The human touch adds drama. The discovery emerged from sleepless nights, analyzing jade spectra with team members from Europe and the United States, debating whether unknown processes like neutron star mergers contributed the metals via kilonovae, short gamma-ray bursts that forge gold and platinum, but the lack of raw process signatures points to stellar explosions alone. This early chemistry ties into habitability, as heavy elements are the building blocks of planets. Without them, no Earth-like worlds, but here they appear too soon, hinting the universe was primed for life far earlier than thought, perhaps with habitable zones forming within the first billion years. Philosophically, this premature alchemy evokes a purposeful cosmos where complexity rushed to emerge, defying the slow grind of entropy toward disorder, suggesting the laws of physics favored rapid diversification in the face of cosmic expansion. Cultural echoes and alchemical myths of turning base to gold, now seen in stellar forges, inspiring art and philosophy to grapple with our metallic origins. Challenges in detection include foreground absorption, but advanced deblending algorithms separated the lines with 99% confidence. Cross-checks with Atacama Large Millimeter Array submillimeter maps confirmed the molecular reservoirs fueling the star's future. With the Roman Space Telescope, wide surveys will census the enrichment globally. The emotional surge is one of wonder. These early metals paint a universe eager to create, leading to carbon-rich disks like the one around star XUE1, a protostar in a distant galaxy at redshift 8.5, about 580 million years old. Its planet-forming disk, surprisingly barren of water, ice yet brimming with carbon dioxide and organic molecules. The James Webb's 2025 mid-infrared spectra revealed a composition 40 times richer in carbon than oxygen, with no hydrated silicates, suggesting ultraviolet radiation from nearby massive stars dissociated water into hydrogen and oxygen, the hydrogen escaping the weak gravity while the rest formed carbon chains into complex organics like methanol and formaldehyde, precursors to amino acids. This alien disk, around a 1 solar mass star, spans 300 astronomical units. Its temperature gradient from 100 Kelvin at the rim to 500 at the inner edge, fostering conditions for pebble accretion, where carbon-rich dust grains coagulate into planetesimals that could birth rocky worlds, rich in diamonds or hydrocarbons, hostile to water-based life, yet teeming with silicon-free biochemistry. Imagine worlds emerging from this disk, super-Earths with carbon atmospheres, where methane rains and ethane seas carve landscapes. The lack of water implies a universe where chemistry takes diverse paths around young stars, bathed in hard radiation. The disk's turbulence, measured by Doppler broadening, indicates magnetorotational instability, driving angular momentum transport and injecting energy to sustain the molecular complexity. Astronomers like Karin Oberg from Harvard explained it as a test tube for astrochemistry, where carbon dominance arises from preferential binding in the cold outer zones. The disk's mass about 1% solar, with a gas-to-dust ratio of 100 to 1 typical for early epochs, but the carbon excess points to supernova enrichment nearby, providing the raw materials. This setup produces alien worlds, perhaps Venus-like, with thick carbon dioxide envelopes trapping heat to 600 degrees or cooler outliers with subsurface carbon, oceans. The implications for exobiology are profound. Life might evolve using silicones instead of proteins or in hydrocarbon solvents, challenging our carbon-water bias. The disk's unexpected fog-clearing ties to galaxies like Jade's global system, redshift 13.1, the earliest known at 330 million years old, emitting strong Lyman alpha light from hydrogen recombination that mysteriously escapes the neutral fog that should engulf it during cosmic dawn. This galaxy, about 1,000 light-years across, with a star formation rate of 10 solar masses per year, punches through the opaque hydrogen sea via a central ionized bubble. Carved by its ultraviolet output, the James Webb spectra showed the line strength, indicating low dust and neutral gas content, perhaps cleared by supernova feedback or black hole outflows, creating a pathway for light at 121 nanometers wavelength to stream out freely. This escape fraction of 50%, far higher than expected, implies the galaxy ionized its surroundings, swiftly contributing to the end of the Dark Ages. Astronomers like Sander Fujimoto from the University of Texas hailed it as the lighthouse of the early universe. Its low metallicity, at 5% solar, allowed clear lines of sight, while the compact size prevented too much absorption. The bubble spans 20,000 light-years, influencing nearby dwarfs in a chain reaction of reionization. This chemistry and light interplay suggests a universe where mysterious emissions and early elements co-evolved, the little red dots perhaps powering the ionization, while carbon disks birthed the next generation. The emotional resonance is a sense of cosmic ingenuity, where light and matter danced from the start. Inspirational outreach with Webb programs let students model the chemistry legacy, shifts paradigms to diverse origins. Poetic in the glow, these mysteries lead to ultimate implications. To deepen the red dots, the compactness implies radii smaller than 1 parsec, with temperatures over 10,000 degrees. From accretion heating, quantitative luminosities at 10 to the 45 ergs per second, straining black hole models. Case studies like dubbed Sears 733 shows broad lines indicating winds at 0.05 light speed. Emerging theories of mini-galaxies with population 3 clusters. Paradigms in seed black hole growth. Global with Subaru for ground spectra. Artistic renders of glowing dots. Rigorous simulations with Ramsey codes. Perspective with Euclid for volumes. Lyrical lights to elemental alchemy. Threads of ionization from dot radiation. Diagnostics of escape cones. Narrative of spectral fitting. Computational in spectral synthesis. Fusions with quantum chemistry. Platforms. Interactive dot hunters. Overcome extinction with multi-band role in education. Red dot puzzles. Youth kits for light experiments. Frameworks. Dot evolution. Pause lights. Bridge to chemistry. Vivid of Lyman alpha forests. Quantitative metal. Yields from pair instability. Forecasts of disk habitability. Personal team. Eureka's tech in grading efficiency. Artistic spectra. Art validations with ALMA collaborations. Data sharing impact. Philosophical origins programs. Virtual chemistry labs. Syntheses. Light matter models. End mysteries to implications. Analogies to earthly lighthouses and fog. Assessments of red dot clustering studies. Individual spectra. Paradigms. Carbon worlds as norms. Efforts with Vera Rubin for transience expressions. Poetic red embers fitting bolometric corrections. Vistas
with aerial for disk, follow-up closure chemistry, to fog clearing, explorations of bubble dynamics, plots, enrichment, timelines, arcs, discovery, collaborations, might AI, for line identification, inspirations, ancient alchemy, tools, open catalogs, subtraction, interlopers, impact cultural diversity, programs, school, telescopes, syntheses, galactic evolution, and the lights illuminate, final shocks.
As the James Webb Space Telescope's revelations cascade through the cosmos, from expansion rifts to monster galaxies and wandering voids, the ultimate implications begin to crystallize into a profound reevaluation of reality itself, starting with those fast-feeding monsters, black holes in the early universe, devouring matter at rates 40 times the Eddington limit, the theoretical cap where radiation pressure should halt accretion. Yet these ancient abysses gorge unchecked, slurping gas clouds at super Eddington speeds to balloon into supermassive titans within mere hundreds of millions of years after the Big Bang, their growth captured in 2025 spectra from the James Webb's near-infrared camera, showing broad emission lines of ionized iron and silicon, indicating accretion disks hotter than 10 million degrees Kelvin, with winds blasting outward at 1/10 the speed of light. The mechanism hinges on clumpy inflows, where dense gas pockets punch through the radiation barrier, allowing episodic feasts that explain the oversized quasars at redshift 10, about 480 million years old, when the universe was just 3% its current age. These monsters imply a universe primed for rapid structure formation, where dark matter halos funneled pristine fuel straight to the cores, bypassing stellar nurseries. The human drama unfolds in heated debates at the American Astronomical Society meetings, where astronomers like Priya Natarajan from Yale argue this violent feeding rewrites black hole seeds as primordial overdensities from inflation, not mere stellar deaths. The implications stretch to the cosmic timeline, squeezing the growth phase from billions to millions of years, potentially seeding the reionization bubble that lit the Dark Ages with ultraviolet fury, while challenging general relativity's event horizon stability. As such rates could warp spacetime into unstable configurations, hinting at quantum corrections near the singularity. Seamless from these ravenous beasts to the sleeping giants, the so-called Sleeping Beauty galaxies, observed by James Webb in the cosmic dawn, halted star formation prematurely when the universe was less than 1 billion years old. These compact systems, about 1/10 the size of the Milky Way, packed with old red stars, yet starved of gas, their disks quiescent like cosmic zombies, defying the expected bursty youth, where starbirth should rage unchecked. The 2025 data from the mid-infrared instrument revealed minimal molecular clouds with carbon monoxide lines, weak and red-shifted, indicating fuel exhaustion or black hole feedback, where central voids blasted out the gas via relativistic jets, quenching the stellar engine prematurely. These galaxies at redshift 8, about 700 million years old, show mass surface densities 10 times higher than peers, suggesting they formed in dense protoclusters where mergers depleted resources. Too soon, the puzzle deepens as James Webb's integral field unit mapped rotation curves, revealing barred structures that funneled gas to the center, only to have it ejected in outflows, spanning kiloparsecs. The astronomers like Francesco Di Eugenio from Cambridge University described the images as ghostly portraits of arrested development, where feedback from active galactic nuclei heated the interstellar medium to 10,000 degrees, preventing collapse into new stars. This quenching implies a biased evolution, where some regions of the cosmic web starved early, leading to red and dead ellipticals by cosmic noon around redshift 6. The implications ripple to galaxy demographics skewing the luminosity function downward at high redshifts, and explaining the overabundance of massive quiescent systems in today's universe. As survivors of this early dormancy, challenging models of hierarchical merging that predicted prolonged star formation, narrative builds to even more unsettling frontiers, the space-time cracks and anomalies glimpsed by James Webb, where quantum foam breaches and potential cosmic strings mar the fabric of reality. Under cosmic extremes, these distortions manifest in gravitational lensing arcs from distant galaxies bent into impossible rings and spectra, showing redshift anomalies not from expansion, but local warps near massive clusters like Abell 3744, where the telescope's 2025 observations captured light delays varying by days across multiple images of the same quasar. The lensing by dark matter clumps, predicted to be smooth, yet James Webb revealed jagged edges, implying filamentary structures finer than 100 parsecs. The anomalies suggest quantum gravity effects bubbling up at megaparsec scales, where space-time smoothness breaks into Planck-length foam, causing light paths to jitter. Unpredictably, the data from the near-infrared spectrograph showed broadened Lyman alpha lines in background galaxies, indicating turbulent propagation through these cracks, hinting at cosmic strings, leftover relics from the inflationary epoch, thin as atoms, yet stretching light years, with tensions equivalent to the Planck mass squared, warping the metric around them. The Discovery team, led by Massimo Stiavelli from the Space Telescope Science Institute, called it a glimpse of the universe's underbelly, where general relativity falters, requiring loop quantum gravity or string theory to smooth the inconsistencies. These cracks could explain the Hubble tension as local variations in the speed of light or dark energy density fluctuating by 5% in voids versus filaments. The philosophical punch lands hard. If space-time is fractured at cosmic scales, our notions of causality and uniformity shatter, opening doors to wormhole traversals or multiverse leaks, where parallel realities bleed through the anomalies, culminating in the grandest vista black hole cosmology, where James Webb's findings propose our entire universe as the interior of a larger black hole. The synchronized galaxy rotations across vast distances, inherited angular momentum from apparent singularity, the expansion tension, as evaporative growth near the horizon, and primordial objects like the little red dots as echoes of the event horizon's glow. This paradigm shift draws from the black hole thermodynamics, where entropy scales with area not volume, and our cosmic microwave background is hawking radiation from the bounding surface. The 2025 spin alignments in over 1,000 galaxies, showing a net vorticity of 0.01 revolutions per megaparsec, suggest the universe spins as a Kerr black hole interior, with the Big Bang as a white hole eruption from the singularity. The fast-feeding monsters then become accretion events from the parent black hole's disk, fueling our growth, while sleeping giants represent regions where feedback halted the inflow, preserving the void's isolation. The space-time cracks align with the Koji horizon instabilities, where causality breaks, for in falling observers, the evidence mounts from the cosmic web's filamentary spins, matching Kerr metric solutions, and the dark energy density, mirroring the cosmological constant from quantum corrections near the horizon. Astronomers like Nayesh Afsordi from the Perimeter Institute argue James Webb's data fits a black hole universe with a parent mass of 10 to the power 100 grams, encompassing all observable matter. The implications are mind-bending. Our isolation, not a bubble, but a feature of the horizon's isolation principle, where information paradoxes resolve through holographic duality. The universe's fate, not a big rip or crunch, but eventual evaporation back to the parent singularity. The human element inspires awe, with theorists like Carlo Rovelli praising the empirical turn toward loop quantum cosmology, where discrete spacetime quanta spin the fabric. These threads weave a tapestry of fragility, where fast feeders and sleepers expose the universe's violent youth. Cracks reveal the quantum underpinnings, and black hole nesting suggests nested infinities. The emotional resonance is a call to humility. Our reality, a fleeting dream within abyssal depths, leading to the conclusion's provocative rap. To expand the fast feeders, the clumpy accretion models with densities 10 to the power minus 20 grams per cubic centimeter allow penetration to the inner disk, where magnetic reconnection flares boost efficiency by 20%. Quantitative accretion rates at 1 solar mass per year, sustained for 100 million years. Case studies like the quasar at redshift 13.2 with luminosity 10 to the power 46 ergs per second. Emerging paradigms in viscous disks with alpha parameter 0.1. Global with Chandra X-ray for corona confirmation. Artistic event. Horizon telescopes renders rigorous general relativistic magneto hydrodynamic simulations. Perspective with LISA for merger waves. Lyrical gorging to quiescent pauses. Threads of Eddington violation via slim disks. Diagnostics of wind compositions. Narrative of spectral decomposition. Computational in Athena code. Fusions with plasma physics. Platforms. Interactive accretion. Visualizers overcome radiation noise with time dilation. Correction role in quasar evolution. Youth workshops on black hole growth. Frameworks. Super Eddington theories. Pause monsters to sleepers. Analogies to black hole therapy in Galaxies. Assessments of feedback. Efficiencies. Studies. Individual quenching events. Paradigms. Early red sequence. Efforts with VLT for optical parallels. Expressions. Poetic. Dormant stars fitting outflow velocities. Vistas with Roman for quiescent census. Closure feeders to giants. Explorations of pair production in disks. Plots luminosity. Functions. Arcs. Team verifications. Might GPU for hydro runs. Inspirations. Ancient voids. Tools. Citizen. Quasar hunts. Subtraction host.
Dilution, impact cultural black hole lore programs. VR singularity, dives syntheses, feeding quenching models, end the gorging quiets to cracks. Vivid, of sleeping beauties. Their surface brightness, μV5. Magnitudes per square arc second, quantitative gas. Fractions below 1% forecasts of reignition by mergers. Personal astronomer. Reflections tech-in, EFU mapping artistic galaxy. Portraits validations, ALMA co maps. Collaborations, data fusion, impact philosophical dormancy programs. School quiescence labs. Syntheses feedback, evolution, end sleepers, bridge to anomalies, analogies to cosmic comus assessments. Mass assembly, histories, studies, bar instabilities, paradigms, blackout feedback, efforts, fast for high, voids expressions, literary silent stars, fitting stellar ages, vistas aerial, for dust-free views, closure sleepers, to fractures explorations of jet, precession plots, quenching timescales, barks, discovery persistence, might AI for morphology, inspirations, mythology slumber, tools, zooniverse, quiescent classifiers, subtraction foreground, clusters impact, art of stillness programs, observatory, quiet nights, syntheses, stellar galactic coevolution, end the quiet cracks open, spacetime, vivid foam, bubbling in voids quantitative Planck scale effects. At 10 to the power minus 35 meters, forecasts of lensing anomalies, personal eureka, in arcs tech, in precision, pointing artistic warped skies, validations, Euclid shear maps, collaborations, international lens hunts, impact relativity tests, programs virtual lensing labs, syntheses quantum relativity, end cracks to black hole, nests analogies, to fabric tiers, assessments, string tensions, studies multiple images, paradigms, cosmic strings efforts, Rubin for transient lenses, expressions, poetic rips fitting delay, times vistas, lynx X-ray lenses, closure anomalies to cosmology, explorations, horizon instabilities, plots spin, parameters, arcs theoretical leaps, might exascale for string sims, inspirations, quantum myths, tools open lens catalogs, subtraction microlensing impact, philosophical causality programs, student string models, syntheses, string gravity frameworks, end the rips, nest realities, vivid Kerr, whirl in cosmos, quantitative angular momentum, J equals 10 to the power 100 h bar, forecasts of frame dragging effects, personal paradigm shifts, tech and spin catalogs, artistic spinning universes, validations, Gaia proper, motions, collaborations, perimeter theory, impact holographic principles, programs, cosmic spin workshops, syntheses, black hole interiors, and the spin concludes cosmic secrets. Further immersion in feeders, the magnetic field, strengths at 10 Gauss in the corona, quantitative pair densities, 10 to the power 15 per cubic centimeter case studies, UL as one black hole, winds emerging in advection-dominated accretion, flows global with Event Horizon Telescope, for shadows, artistic maw, depictions rigorous ray tracing, for light paths, perspective with NGEE, for event resolutions, lyrical devouring threads, diagnostics of Fez K alpha lines, narrative fitting cycles, computational, flash codes, fusions, astroparticle platforms, visualizer apps, overcome flare variability, roll youth black hole feeders, youth kits, feeding models frameworks, slim disk, end feeders, deepen sleep, quantitative feedback, energy ergs, 10 to the power 51 forecasts dormancy, durations personal team, bonds tech bar, patterns speeds artistic red voids, validations, see us spectra, collaborations, ALMA starburst, impact quenching mechanisms, programs gas depletion, labs, syntheses ag and feedback, end sleep to crack, vivid lensing caustics, quantitative deflection angles, arc seconds, forecasts dark clump masses, personal anomaly, hunts, tech deconvolution, artistic, bent lights, validations, Hubble J, Jabrids, collaborations, lens conferences, impact isotropy, challenges, programs, lensing games, synthesis, foam string end, crack to black hole, vivid horizon glow, quantitative entropy say equals area, over 4L Planck squared, forecasts evaporation, times personal cosmology, turns tech, holography, artistic nested voids, validations, KMB spin, collaborations theory empiric impact, multiverse doors, programs, black hole universe sims, syntheses, Kerr Simbi, end, the nest wraps the tail. As the James Webb Space Telescope's golden eye continues to unravel the universe's deepest secrets, from the Hubble tension's cosmic speed glitch, hinting at a fractured expansion rate where local measurements clock galaxies fleeing at 73 kilometers per second per megaparsec, while ancient light whispers, 67 painting, a picture of dynamic dark energy that might ebb and flow like a living force to the monster galaxies, bursting forth at 330 million years old, 6 behemoths, each tens of billions of solar masses, strong defying the slow build of stellar nurseries, with explosive direct collapses that seeded the cosmic web's earliest threads, wandering black holes like quasar object, one roaming naked at 50 million solar masses,
without a galactic home born from primordial quantum ripples to feast on pristine gas in isolation. Cosmic collisions in the infinity galaxy, where two spirals smash into an eternal loop, suspending a 100 million solar mass void in gravitational limbo, fueling starbursts that light the dawn. Rogue worlds in Orion's nebula, over 500 Jupiter-sized orphans in binary pairs, screaming radio bursts from tangled magnetic fields, 10 times Jupiter's fury, their iron rain atmospheres, a testament to resilient chemistry. In the void, mysterious lights as little red dots, over 300 crimson enigmas at redshift 7, brighter than trillions of suns, possibly black hole seeds or novel entities piercing the neutral fog, with Lyman alpha escape, fractions of 50%, and early chemistry forging oxygen and carbon in population. 3 stars exploding in pair instability, blasts to enrich the cosmos. 200 million years post-Big Bang, ultimate implications, weaving fast-feeding voids at 40 times Eddington, limits sleeping beauty galaxies, quenching prematurely in feedback, quakes spacetime, cracks from quantum foam and cosmic strings, warping lensing, arcs, and the grand black hole, cosmology, where our spinning universe spins as a Kerr interior, inheriting angular momentum from apparent singularity. These revelations converge, not just as scientific triumphs, but as a mirror to our own potential, in a manifestation-driven reality, where quantum observer effects echo the early star's will to ignite, and galaxies' defiance of entropy whispers that consciousness shapes timelines, just as these anomalies challenge uniform laws, reminding us that the universe, like our thoughts, expands unevenly, with hidden accelerations and sudden bursts urging us to harness the law of attraction amid cosmic chaos for personal transformations that parallel the Big Bang's bold rebirth. James Webb, launched in 2021, but thriving in 2025, with discoveries like the carbon-rich disks around protostars at 625 light-years, and auroras on Neptune, brighter than Earth's, or the 29th moon of Uranus, named S/2025 U1, proves Einstein's gravity eightfold in lensing rings, while interstellar comet 3 I/ATLAS reveals alien chemistry from distant suns. Each find a call to action, to visualize abundance in the void, trust the unseen forces pulling rogue worlds into harmony, and collide with life's challenges to forge new infinities as the telescope peers to redshift 20 back to 180 million years cosmic time. It invites us to rewrite our stories, not as passive observers, but as co-creators in this quantum tapestry, where the first galaxies at redshift 15, around 270 million years old, teach that from darkness blooms light, and from tension emerges evolution. So gaze upward, channel that cosmic energy, and manifest your universe anew. For in the stars' defiant dance, we see our own power to shift realities and attract the extraordinary. 吉波之握